the music that we choose. It's 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 the music that we choose. The music that we choose. The world is spinning too fast.
Software engineering is basically the application of systematic, disciplined, quantifiable approach to the design, development, operation, and maintenance of software, and also the study of these approaches, which basically is the application of engineering to software. It's basically just taking your engineering and putting it into software and making software that reflects this.
Some subdisciplines include software requirements, software design, construction, maintenance, configuration management, engineering process, and engineering tools and methods, and software quality.
They don't really use basic textbook math. Instead, they use the analysis skills they learn in math, your ability to think through a problem and basically figure out what is what, and they apply that to their software and their programming and such. They also sort of use formulas. They don't really necessarily use something like the quadratic formula or an actual formula that's used in math. It's more of the knowledge of formulas and understanding that formulas are sort of like programming languages and orders for the computer and such. You need to understand what to use in what situation. Also, they use the discipline learned in math to solve a problem. That is, your ability to keep going in math translates directly to programming, because programming is very intensive when it comes to focus, because as soon as you have something done, there are bugs all over it. You gotta search through everything and fix them. And you gotta have that discipline you learn in math to be able to do the programming. And also the satisfaction solving a problem. If you know for math how happy you are when you solve a really, really tricky problem, that same thing applies to programming. When you finally get a finished product, it feels really good.
So all software engineers have to take Calculus 1 and Calculus 2, and it's advised that if you don't fully grasp the concepts in Calculus 2, that you take it again. And some choose to go on to take Calculus 3, but that's not required. There are several programming and computer science classes that you can take after that as well.
And that's pretty much software engineering and software engineers.
Thank you for doing this interview. It's for my pre-calculus class, and we're trying to see how math relates to different occupations. So I just want to start off with getting to know you a little bit. So can you tell me where you went to school and what you studied?
Actually, my name is Laura Campbell. I work at Archer Daniels Midland as a web developer. I actually grew up here in Bloomington, so I went to Normal Community, and then I went to Eastern Illinois University, and I got my degree in mathematics and computer science.
Okay. So what kind of classes did that entail?
For me, it was Calculus 1, 2, and 3, and then a couple probability and statistics course, and then a linear algebra course, and those are the ones off the top of my head that are math related. And then there were a bunch of computer science courses, so computer science 1, 2, data structures, and also theory of computation, so whole slew of courses to deal with that.
I see. Okay. So can you tell me a little bit about your current job?
Oh yeah, sure. So as a web developer, I develop our warehouse management system. And so basically I'm tracking pallets that go in and out of the warehouses, just making sure we know where they are at all times, and also what's on those pallets, and how much of a product that we produce that's on those. So lots going on there. That's a web interface for our users in the warehouses.
Okay. So, what would you say, what type of math is most relevant to your current position?
I think the biggest takeaway that I took from my college courses is just the logic that goes into it. Just a lot of critical and analytical thinking in that. And then, once in a while I do get a weird math problem out of the blue. Since I deal with pallets, I usually have to deal with barcoding. And so I will design the barcode labels, if you know Microsoft Paint, we have a program that I wrote that I can rotate the labels around, and that, for example, is actually, you can think of as a matrix rotating around. So a little bit of matrix arithmetic and sometimes even probability and statistics we have to use. Like I had to tell them the amount of pallet IDs that I could generate with the numbers 1 through 9, and then including the letters A through Z without the vowels included. So a little bit of everything that gets thrown in there. I mean, you just never know what you get from your day-to-day job, and so it's nice to have a background in a little bit of everything.
Okay. So how would you rate the demand from employers for people with your degree?
Oh, it's very high. I can easily find a position, I think, anywhere. I mean, you can probably just go on a website right now and just type in programmer or web developer, and you're going to get a lot of hits, no matter where you are in the country. It's something that's so high in demand that, you know, sometimes they have to go to another country to outsource jobs and things. That's a touchy subject, though, so maybe let's move on.
Okay, sure. So how vital is math in your job?
I think it's mainly the logic skills that you gain. I'm pretty sure that, you know, it's the ability to look at a problem and say, you know, okay, I need to go through steps A, B, and C in order to get to this result. Some people, you know, can't define those steps, and so, you know, that's something that I think I took away from my math classes, just analytical thinking.
Okay. So what area of math do you wish you would have studied a little bit more that you felt like maybe was neglected that you could use in the real world?
That's a touchy one. I think one of the ones that I wish I would have done was more in discrete mathematics. That one that involves proofs, and that would involve, like, say I write a computer method. I can say, well, I know this method would work if I knew how to do those proofs. It's just that's something that I wish that I would be more comfortable, because as you can see, I'm a little floundering on how to describe it. So it's just something that would be nice to know a little bit more about.
All right. So mathematically speaking, what is the most difficult part of your job?
I think it is, I keep on going back to it, but just trying to define the different parts of the problem and trying to figure out how to break it up into those smaller steps. I think that's pretty much it.
All right. So thank you. I really appreciate it.
Yep, no problem.
Got off the plane to the